Okay. Okay, next up, we have, again, a three-part. This is even more complicated. I'm not sure if anybody, other session had to do timing for 3 individuals back to back here, letting them know how much time each of them has. So we have integration of OpenTopography into CyberGIS Gateway enabled by GIS Solve, an application-driven approach. Nancy Wilkins-Diehr, Anand Padmanabhan, and Ming Wang. But in terms of the authorship, it's a slightly different authorship. As you can see up here, Nancy is standing in for Chuhan. Chuhan couldn't be here today.
Right.
So Nancy, I understand you have about 15 minutes?
Yeah, and I'll be quick. I might be able to catch up. Having not done the actual work, I can be a lot quicker. So I'm representing the work of Chunhan Yoon at SDSC. Chunhan is in Korea right now for a special ceremony for his brother and regrets that he cannot be here with us today. So I was interested to hear a couple of things this afternoon. Number one, Dan Atkins' reference to the fact that everyone and their brother wants to stand up gateways today, as the originator of that phrase about 7 or 8 years ago and running that program in TerraGrid. I'm really happy to hear that. I hope that we're not heading for the trough of disillusionment after the peak of the hype on this curve here, but I really think that gateways can have quite a lot of impact, and the work that we're going to talk about today is the integration of 2 independent standalone gateways and kind of the importance of that. Dan Katz earlier today referenced the software integration level of that SI2 program. That's where CyberGIS sits. So we're integrating multiple independent activities, and there are difficulties and advantages to that, and that's some of what we'll show today. So I wanted to motivate gateways just a little bit. We've heard a lot about them over the last couple of days, whether they've been called that or Portal Palooza that Dawn mentioned in her talk. They go by a number of different names, but they can, we heard some about NanoHub also from Dan Atkins. So there are lots of examples out there. The way we came up with the term, and Rick Stevens actually initiated it in TerraGrid, was really looking at the beginning of the TerraGrid program. You've got these high-performance computers, and you've got these increasingly capable web interfaces. And how can those high-performance computers have more of an impact? And we thought, well, by integrating them onto the back end, you've got these same familiar front-end interfaces. All of a sudden, you've got more power. You can do more analysis. Basically this CyberGIS idea. And so there's a number of things motivating that. Data deluge has been brought up several times. And really, it's only about 20 years right now since Mosaic was developed here at NCSA. And that's a short amount of time to have an impact on how people conduct their research. So I think there's really a lot more to come in this area. So when I started doing my computing, this is about what things looked like. This is a VT100. I started on a VT220, so the next model up. And this is what my interface looks like to one of the supercomputers, Ranger at Texas today. So you can see that those two aren't a lot different in 20 years. But the world around supercomputing has changed quite a bit. Some of the things that gateways allow us to do, a number of different things, mostly solving some of the undifferentiated heavy lifting problems, coupling multi-scale codes, learning how to run on batch systems, things that you don't want each and every domain scientist to have to learn over and over again. But what we've really seen is that they really open up this access to the wider community. So when we think from a supercomputing perspective, we think, okay, there's a principal investigator, gets an account on the system, has a small research group, they get to log in and run jobs. That's a limited, there's a limited impact with that. So gateways, once you open things up to the web, you instantly increase the impact that you can have. So we, let's see, I think I've got this in a couple of slides. Yeah. We recently learned the Cypress Gateway, let's see, down here at the bottom. This is the front page of the NSF website from just a couple of weeks ago. So we have this Cypress Gateway. It runs phylogenetic codes on some of the supercomputers in Exceed. And the principal investigator noticed somebody using an awful lot of time. So they log into the gateway. They don't have an account on a supercomputer, blah, blah, blah. So he contacts this person, hey, what are you doing? You're using a lot of time on this gateway. Notices that it's a K12 12 email address. So it turns out that we had a 15-year-old who won the Massachusetts State Science Fair by using this gateway running on supercomputers. Never had any association with any of us, no help desk interactions, just had a teacher who found this gateway and was able to get this person going. So that, to me, is a great illustration of the democratization that's possible through gateways, and also the impact that having access to those resources can have on the next generation. So this student came to Exceed 12 a couple of weeks ago with his grandma. I got to meet both of them in person, and is tremendously excited about science and engineering now, because of that experience. So in Exceed, we've got a lot of different gateways, and what's interesting about CyberGIS compared to this is because we've got so many different domains here, we don't often see them exchanging information. So tornado formation doesn't have a lot to do with nanotechnology, doesn't have a lot to do with phylogenetics, so we're not doing a lot of integration across gateways. For GIS, that's entirely different. I mean, what I've heard just over the last couple of days today is all kinds of data sets that could be interchanged because they're all spatially related. So there are a lot more challenges than the types of things that we've seen in TerraGrid. So now to the coupling problem with OpenTopography and the CyberGIS Gateway. So those of you that were here on the Monday, we did a nice little hands-on demo. I think it was probably back in the morning on the Monday. And everything looked fairly seamless. You went through CyberGIS. We all got logins. We created new data sets. We'll have a short video of what we did, minute and a half, I think, at the end of this talk. So those of you that weren't here on Monday could see how it worked. But it looked absolutely seamless. You could click on the USGS data set. You could click on the OpenTopography data set. You could create maps, and we did a viewshed analysis. And from the surface, that looked quite easy. This talk is going to be about why, what made it look that easy, because this is coupling two entirely different, well, three actually, with the USGS data. Three entirely different standalone systems, so you didn't have to log on twice. One gateway didn't have to know who you were on the others. There's a lot of tricks behind the scenes, and I can see this being increasingly useful in this GIS world because of the interoperability of the data. Right, so we wanted to, make use of the assets of both systems. So what services was OT exposing? What interfaces did they have? What services did CyberGIS want to pick up? What user interfaces did they have? And some of my collaborators are going to speak to those points. But kind of taking the best of both and integrating them for a larger purpose. So OpenTopography. Chris Crosby leads this. He was at SDSC until just recently, leaving for UNAVCO out in Boulder. So this is an NSF facility basically providing access to high-resolution LiDAR data. So OT has about 700 users. We heard that CyberGIS has also 600-700 users. So you've got big, independent user communities. And what we're hoping is that, this integration can benefit the OT user community. It can benefit the CyberGIS user community, winning all around. So here, I believe I'm switching off to Anand. Yes? Yes. Probably under 15 minutes, yes? Not bad. Is that good? I think we were going to switch in. That's okay.
Okay, I think this talks about the OpenTopography service architecture. Shuhan would be able to better explain the details of this architecture, but suffice to say that this is quite complicated. And this is our CyberGIS Gateway. It represents, as we saw on the first day, a broad dimension to have people interact and be able to use the gateway pretty reasonably well. So it is for a wide access to a general public. And through the gateway, we hope they will have access to the cyber infrastructure environment seamlessly. The application driver, the particular application driver for this integration was the viewshed application. The viewshed application, as we saw on day one, has basically, you have a terrain data and you have a bunch of points on the terrain data and you want to see what's visible or what can be visible from that point. As we saw on Monday, we have multiple data sources. You could input your own data set, you could have OpenTopography data set, and you have USGS as a third data set. This particular talk is just trying to tell you more about how the integration was actually achieved in the back end in order to give you that seamless interface. So some of the challenges for doing this integration was we had to do the integration at a user interface level, because these were two separately, as Nancy told you, that these were two separately and independently developed gateways. We had, since this was a data data source which we were providing, we had to do data discovery and using metadata and stuff like that. And we had to do service chaining. So the end product needed by this particular application was a DEM data. Well, the data stored in OpenTopography is a point cloud data. So there has to be service chaining, and this does not need to be visible to the user. And finally, we are crossing two independent security domains, so we have to do security aspects of it. So how was the integration approach for each of these? We basically have two levels of integration. We have the service level integration and we had the gateway level integration. The service level integration had the security, which was enabled by the GIS Open Service API, and we used token-based identity service. The service chaining was done through a workflow, composing the workflow system, which was part of the GIS middleware. And we use metadata services, which OT was providing us. They have two metadata services, which I'll talk about in the next slide. And finally, we had the interface, the user interface, which was combined together using the shared libraries, which basically JavaScript libraries, which are provided through OpenTopography. I'll start working from the bottom up, and I'll cover the first three, and Minghua will cover the last, the user interface, since he did a lot of work there. The security aspect of it, as we saw on day one, when Yan was doing the demo, we have a GIS Open Service API. It has a security API, which is based on token, and which does authentication and provides ability to do authorization. So OpenTopography has the services. They were exposed using Opal Web Services. And the Opal Web Services actually, so how the workflow worked was, when a user logged into the gateway and wanted to use OpenTopography service or data, the gateway, on behalf of the user, contacted our token service, generated a token, and then passed this token on to the OpenTopography server, which in turn verified it with our token services. This, as you can see, this is similar to if you know security environment. This is similar to other token security models which have been adopted by other gateway. And we are there is a project on gateway security at NCSA, which is, I think, even collaborating with Exceed, trying to bring all the gateways together to use a common security model, and we are working with them. So that's how we did security. So the next part was we had to do the service chaining, and these were the basic services from OpenTopography we are using to do this integration. The cloud, Count Cloud is one of the services which OpenTopography provides to tell you how many points are there in the bounding box you select. This is there because at the current stage, they are able to process 150 million point clouds. If you're over that, they are not able to process it. So this gives you a way to check so that you don't have failures. The other thing is to actually select the data. So you select the point cloud data, that's the data selection service, and point to grid is actually a service which converts this point cloud data into a DEM, which is digital elevation model, which is what is needed as an input for viewshed analysis. And there are various ways of doing converting from point cloud to a DEM data, and there are various parameters which we pass through. And these are all kind of hidden from the user. And finally, there is a format translation service to translate from an R grid, which was the format which OpenTopography was generating, into a GeoTIFF data, which was what was being used by viewshed. The service, Chaining was done as part of GISOL middleware and using the GISOL Open Services API. And we basically streamlined the service invocations, and it relied on the Open Service API, Security API in order to do these token exchanges. Finally, each of these services is not an instantaneous return. So you actually do a service, you make a service call, you have to wait for, because you're selecting 150 million data points. So it might take a while to get them selected, to get them translated. So each of these service has a start, and then you have to check whether these services has been completed or there was failure, and all these handling are taken care of by this chaining service. Finally, the data discovery service or the metadata service. OT provides two metadata services. One is in form of the Google Fusion table, which stores the vector data. The vector data is basically polygon data, so you could show them on the map so user can select what the region of interest. And the second is the catalog service for the web, CSW, or as it's called. It's a OGC standard catalog service. That's a standards-based catalog service, and that's the ISO number for it. And that basically provides us various other information about the data set. For example, its bounding box, its a projection system, which the data is at, because OT data is a LiDAR data. Each of these regions are in different projection systems, so that information is highly important. And the vertical feed, that is one of the important information, whether it's in feet or in meter. That's important information for this particular thing. And basically, so this is the workflow of the backend system. I'll not go through it in detail, but basically the web service, which is the GISOL Gateway, contacts the metadata service in order to get the metadata information, and the GISOL middleware or the through the Open Services API communicate with the OT gateway. So that's the part of my talk. I'll let Ming-Hua finish this talk. She is going to talk about the last level of the interface, which is the integrating the user interface part. Thank you.
I will talk about the interface level integration of these two science gateways. So as Nancy and Anand highlighted, these two science gateways have been developed independently, and so they already have some pre-built user interfaces. So for example, the CyberGIS Gateway has interfaces for data selection and viewshed analysis. And the OpenTopography Gateway have a Google Map-based interface for searching LiDAR data sets and retrieving point cloud data, and also for generating DEM from the selected LiDAR data sets. So the challenge here was to integrate these existing user interfaces without reinventing the wheel entirely. So the interface integration was carried out in 3 steps. The first step was to wrap the existing OT user interface so that it can be part of the CyberGIS Gateway. So initially, this task seemed challenging because two science gateways use different web mapping APIs. So OT interface used Google Maps API, and the CyberGIS Gateway used the OpenLayers API. So we worried about how we will implement this OT functionality. But fortunately, the OT team developed this interface as reusable JavaScript gate library, so we could simply import it to CyberGIS Gateway and then make the look and feel of this interface consistent with the other CyberGIS Gateway interfaces. So using the reusable library helped this integration to a great extent. So the next step was to link these two different interfaces. So we linked the OT user interface with other CyberGIS Gateway interfaces. So as you've seen, some of you seen in the Monday, so now OT dataset is listed one data source for the CyberGIS Gateway, and also user can select a dataset from OT without knowing this data is coming from OT Science Gateway, and also they can see the bounding box of also data extent of this OT dataset within CyberGIS Gateway. So the last step was we had to add some functionality to existing user interface for input data validation and also for some additional metadata collection. This step was necessary because existing CyberGIS and OT services have some restrictions on the input datasets. For example, the OT services currently allow the user to retrieve up to 50 million cloud points per request. And also the CyberGIS viewshed analysis service, they can deal with up to 100 million raster cells per DEM. So we, through the user interface integration, we had to ensure when users select a study area, this area is varied so that they can deal with proper data sets. And also, as Anand explained before, in the backend, there is a lot of the data transfer and transformation. So to ensure the validity of this process, we collected several additional metadata, such as ID of data set, bounding box, and coordinate system, and passed that information to backend service chain. So one important aspect of this integrated interface is that it requires multiple interaction with the OT metadata services. So for example, the data selection interface is a way to show metadata. So the locations on the Google Map API, it is where the OT data collected, and also it shows who collected the OT data and also when the survey was carried out. And this information all comes from Google Fusion table provided by OT team. And also, when users select a data set, this interface contacts the CSW metadata service to get additional metadata. And so the interaction between interfaces supported by metadata services. So when users switch back to the CyberGIS Gateway, the spatial extent of this OT dataset was visualized as a KML layer on the CyberGIS Gateway map interface. And this information also comes from Google Fusion table. And at last point, when users select a study area, this interface checks if this study area includes a proper number of cloud points, so that they can pass valid input parameters to the backend services. So in addition to the user interface components, these metadata services played a key role in integrating the interfaces of these two science gateways. They did so because they provide some intelligence for data validation and also the backend data transformation. So now I will back to Nancy.
Thank you. Just about done here, Tim. The next one is, so this is, let's see if this, right. So this is a video of the work that we all did on the first day. So this is going into CyberGIS and creating a, I don't know if this is, sometimes this runs a bit slow, so we'll jump out of it, Tim, if it doesn't run fast enough. Yeah, it started around. Yeah, right. Right. So we're creating a new problem set, and this is what looks so simple. So where you see cigi-GIS and OpenTopography, all the work that was described by my collaborators here are the behind-the-scenes thing to make those data sets appear as if they're just part of CyberGIS. So it seems very, very seamless. There's a lot of work that goes into integrating these disparate standalone gateways, and it all looks very seamless. It worked quite nicely for us on Monday, and this is really just a snapshot of exactly what those of us that were here on Monday walked through. But there's a lot that goes on behind the scenes, so you don't always appreciate the complexity when you just see how nicely things work. That's what you want. You want that streamlined UI. We talked about that a lot over the last couple of days. But there's some work under the scenes to do that. What it buys you is that you don't have to reproduce these very large high-resolution LiDAR data sets at multiple places, right? So OpenTopography's got it. You can just go grab it from there. You see USGS has it. You can just go grab it from there. So you're not duplicating. You're just taking advantage and building off of those things. It just takes a little bit behind the scenes to do that. And I think that's probably the end of that guy. Right, so yes, Tim's anxious for us to go. So I think I really talked through most of this through the short video, just the advantages to interoperability of standard standalone gateways. Acknowledgements. These are not the views of the National Science Foundation. And that's it.
Thanks, Nancy, Anand, and Ming-Ma. Yeah. Questions? A couple of questions. Jan? Okay. Yeah. Couple of questions. Jan's the next speaker. Dan?
So it was nice to hear that there are quite a few gateways or portals or hubs or whatever. Can you make any comment about the extent to which they're using any common infrastructure or the extent to which they're all reinventing the wheel?
Yeah, so that was actually that was one of the benefits that we saw in the TerraGrid Science Gateway program was, in addition to using the high-end infrastructure, what it gave developers was a platform to share approaches, because there were a heck of a lot of similarities. So a lot of fault tolerance work that the lead gateway did when they were doing these weather challenges was also something that got incorporated into this gateway out of San Antonio, Texas, that is like a lab system for a spinning ultracentrifuge, and people send in remote samples and they do this analysis. So totally independent domains, but they could use a lot of the same workflow. They could use a lot of the same fault tolerance. So I think that sense of community that the TerraGrid Gateway program gave those developers was really, really valuable, because there were a lot of things that could be done similarly. We have high hopes for a software institute around gateways to share that that same kind of approach with developers who are not just using the high-end back-end. So that was the commonality in TerraGrid. But there's individualization, but there's a lot of room for common. You do have this sort of undifferentiated heavy lifting that everyone has to do that can be adapted across. So
I just briefly say I sometimes use the term, instead of 4-quadrant, I'd say all-quadrant, and the additional dimension is interoperability between knowledge communities. And I think it's important that we think about that as well.
That's exactly what these GIS activities bring in a way that we never had in the Gateway program, because these are so interrelated, some of these gateways. So,
just a quick question. You're talking gateways, and Dan, when he said something, he mentioned portals, and we would call it a viewer, I think. Are all these things the same thing? I mean,
yeah, it's the same thing.
Viewer is like a gateway because it provides you access to all our data and everything else. So, so terminology, all that, all means
same thing. Yeah.
I say, I use the term collaboratory as an environment where you do work, and I'll accept gateway if the gateway is the door into the collaboratory. But simply something that displays information and doesn't support a community leading towards this functionally complete notion, I think is not.
That's a good distinction.
I mean,
yeah.
Okay, I think we'll move on now. Let's thank the speakers once again.